For this video, we are tasked to solve for the remaining unknown measurements of this right triangle. Please be guided that a triangle is a polygon with 3 sides and also be considered as a polygon with 3 angles. In short, we are to complete 6 unknown measurements, if there are, for this given triangle. But we are already given with the measurement of this angle and the measurement of this side, which also relevant here as this is also given, for we know that this is a 90-degree angle. Hence, we now know that we are to solve 1 remaining angle measurement and 2 side measurements. In order for us to solve this, we need to anchor on 2 important theorems for right triangles, which is the Pythagorean theorem and the triangle angle sum theorem. However, the Pythagorean theorem cannot be used here since we need 2 sides for us to solve for the remaining unknown side measurement. But here, we are only given with 1. In short, we need to use trigonometric functions in order for us to solve for x and y. But first, let us solve for angle theta. This angle theta may be solved by looking into the relationship of the sum of the measurements of the angles of the given triangle. We know, using triangle angle sum, that the sum of these 3 angles must measure to 180 degrees, and hence we can solve for the measurement of angle theta by subtracting the measurements given from 180 degrees being the sum of the measurements of the angles of interior angles of any given triangle, which measures 90 degrees, and we will be subtracting the given measurement for this angle, 15 degrees. Therefore, the value of theta will be the result when we subtract 90 and 15 degrees to 180 degrees, which will give us a measurement of 75 degrees. We can also draw important relationships between the 2 non-90 degree angle, and since these 2 must sum up 90 degrees, in short, they are complementary. My point here is, when we subtract 180 to 90, we will get here a result of 90 degrees. Hence, we are really convinced that the sum of the 2 acute angles would be resulting to 90 degrees, and hence they are complementary. So if we're going to subtract 90 or 15 degrees from 90 degrees, you will still get the same result of 75 degrees. So this is how we solve for the unknown measurement of the remaining angle. As for the sides, again, we cannot use the Pythagorean theorem, but we can anchor on the trigonometric functions in order for us to solve for this. But in order for us to determine which trigonometric function we're going to use, whether it's cosine, sine, or tangent, we need to look at the given measurement and the side measurement we are trying to solve. Here, the given measurement, 12, is the hypotenuse of our right triangle. In short, the hypotenuse is already given. And if we are going to solve for x, x being the opposite side of the reference angle of 15, and y would be the remaining side, which is the adjacent side. So looking into our given and the value that we are trying to solve, we are going to look into the relationship of the trigonometric function which use opposite and hypotenuse. In this case, we are going to use for sine, and that would be sine of the given angle, sine 15 degrees, must be equal to the opposite, which is x, all over your hypotenuse, which is 12. In this case, we are just going to apply the fundamental law of proportion, being this trigonometric function be equal to 1, and we are going to multiply or cross multiply the values. So we have here 12 times sine 15 degrees. This is sine 15 degrees, which will result to the value of x. Applying the symmetric property, x is the result when we multiply 12 and sine the value of the given angle 15 degrees. For this given value, since this may not be exact, let's symbol of approximation, and we will get a value rounded off into 2 decimal places, 3.11. And since this is a measurement of side and there is no given measurement unit of measurement for the side, let's just use units. So x is approximately equal to 3.11 units. To solve for y, let me increase this side here. And we may also use another trigonometric function, which will use the given measurement 12 as a hypotenuse and the y that we are going to solve here. So since we are solving for y, we will be using adjacent and hypotenuse. In this case, we will be using cosine. So cosine 15 degrees is equal to the ratio of the adjacent side, y, over the given value of the hypotenuse being 12. Same as earlier, we can use cross multiply here, or the fundamental of proportion, so you will get a value of 12 times cosine 15 degrees. This will be the expression that we are going to use to solve for the value of y. By symmetric property, y, and since this is not exact, approximately equal to the value when we multiply 12 and cosine 15. This will result to a value approximately in 2 decimal places, rounded off into 2 decimal places, 11.59 units. So these are the values of the unknown measurements of this given triangle, 1 for angle and 2 for x and y sides with this given value.